Okay, cool. So one thing I do want you to keep in mind is that when it comes to the test itself, all of the questions are going to be all jumbled up, so you're not necessarily going to know which section questions are coming from. Although this one's pretty obvious because this one's just directly saying to expand the quotient. Okay. The problem with this particular question is that the numerator and the denominator already have the same degree, which means before you even start doing partial fraction decomposition, we need to just divide the two things first. So let me pull up my notebook here. Okay, so just kind of copying down what they're giving us, x squared plus 9 over the x squared minus 5x plus 6. Anytime the degrees are the same, or if the numerator has a bigger degree, always do long division first. So here we're going to have the x squared minus 5x plus 6, and we're going to divide that into x squared plus 0x plus 9. Always make sure you put in that ghost term for anything that's missing. I don't know why I put my 2 like way up there. Whoops. X squared plus 0x plus 9. Okay, so x squared goes into x squared just once. We're going to multiply that 1 times this whole thing, x squared minus 5x plus 6. Here's where you really need to be careful because you have to subtract this whole thing away. X squared minus x squared is just 0. But then we have 0 minus negative 5. The double negative is going to change that into a positive 5x. Then we have 9 minus 6, which is plus 3. All right, so that's going to be our remainder here. So what we have is this thing up top here. Let me make my notebook bigger. This thing that we started with, this fraction here, can be broken up. It's going to be broken up into the quotient 1 plus the remainder, 5x plus 3, all divided by this x squared minus 5x plus 6. Okay, now what we want to do is we want to take this and break that up using partial fraction decomposition. Not the 1, of course, but the other part of it. So this 5x plus 3, all divided by the x squared minus 5x plus 6. Let's try to break that up. To break that up, first we're going to have to factor that denominator. It should factor into x minus 3 and x minus 2. Right? Because the negative 3 and the negative 2 multiply to be positive 6. They add together to be that negative 5. That means that the partial fraction decomposition, because you have two linear terms in the bottom, is going to be a constant over the first linear term plus a constant over the second linear term. All right, now we do what we always do. We're going to multiply both sides by the common denominator. That'll leave us 5x plus 3 on the left. That a comes down, and then we're going to have x minus 2. That's because the x minus 3 is canceled. But the second one there, the x minus 2 is canceled, and we get x minus 3. All right, we're trying to figure out the a and the b that's going to make this work. I think I showed you two different techniques in the videos here. I'm probably going to use the easier technique for this one, which is just trying different x values. Instead, if you were with us on Thursday, I think when we did these, I only did that other method with the coefficients. So I'm going to try x to be 2, because I know if I do plug a positive 2 in, it's going to make this whole parentheses just go to 0. So when I plug x to be 2 on the left, I have 5 times 2, which is 10, plus the 3 is 13. When I plug it into this, I'm going to get 0, plus, if I plug it in over here, 2 minus 3 is negative 1, and then negative 1 on that b is negative b. So what I get is 13 is equal to negative b, which means that positive b is going to be equal to negative 13. Okay, so there's the b. We also want to try to find the a, so let's just try a different x value. Let's try 3 this time. Again, because I know if I plug 3 in, it's going to make this parentheses go to 0. So plugging 3 into the left, I get 15 plus 3, which is 18. On the right-hand side, I get 3 minus 2, which is 1, so I get the a, plus, remember this whole thing over here on the right-hand side, 3 minus 3 is 0. So I get a is equal to 18. Okay. So then using this, I'm going to plug these coefficients back into my partial fraction decomposition for up here. It was a over x minus 3, and then b over x minus 2. So that means that that whole thing up top there is going to be a, 18, over the x minus 3, plus the b, negative 13, over the x minus 2. But where you have to be very careful is that don't forget, we also had that 1 from way up here, this one. So really it's going to be 1 plus these two things. Alright, so just to type it in, make sure we're right. Cool. Alright, so again, the big key for this one was the degrees of the polynomials. When the degrees are the same, or if the degree up top is bigger, long division first. Whatever you're left over with the remainder, then do partial fraction decomposition with that. If they did ask you to integrate over this, then the antiderivative, 1 would go to x. This next one would be 18 natural log of the x minus 3. And then minus 13 natural log of the x minus 2. These are supposed to be absolute values. Okay, did that help? Was that alright for that one? Any other homework questions? See what my grade is now that I've been working with you guys. A 12. Not great.
Hello, Otto.
Richard, you're so loud. Alright, I'm muting you, Richard. No offense. I can find you. Any other homework questions? I do want to point out, as you guys are searching for homework questions, so here in our Moodle page, if you go down to the bottom of the chapter 8 thing, you know, past all the million videos, way down here. So here I have a little practice thing. I named it a silly thing, but this practice stuff, this is a pretty good practice when it comes to the chapter 8 test. I think it has pretty much everything on there that you're going to need to worry about. And then this other thing I have is the solutions to this practice. I think next week, depending on how many homework questions you guys have, we'll probably just kind of go over most of these together. So just kind of giving you a heads up. And I would recommend this, work on this a little bit ahead of time. That way when we work it on all together, you'll kind of see the mistakes that you made. Okay, but back to homework. Any other homework questions, section 3, 4, or 5? Or even next week's homework, if you guys want to start looking at that. Okay. Well, if there's no questions, we don't have to stick around. Oh, okay, we got one. All right, nobody move. Section 5, number 6. Okay, express the given integrand as a sum of partial fractions and then evaluate. All right, cool. So just copying it down, the integral from 1/3 to 1 to y plus 6 over y squared plus 2y dy. Okay, yeah. So let's talk about first answering this question if we did not have the info that it wants us to do partial fractions. We would start at the beginning with all those different techniques that we've talked about, right? So first off, u substitution. And this looks very close to a u substitution. If I let u be that denominator, y squared plus 2y, du would then be the differential of that 2y plus 2, which is almost what we have up top. Okay. But it's not quite, and there's no way that we can manipulate it so that it is going to be exactly what's up top. So that means that u substitution is out. Maybe you could finagle with it and force there to be a u substitution, but it just wouldn't be worth it. All right, after that, integration by parts probably wouldn't make sense here. You could try completing the square there in the denominator. That actually might work, completing the square, but let's not do that because the bottom can be factored, and it can be factored so nicely that we can do partial fractions. So let's go over to scratch paper. And in our scratch paper, we're going to take that fraction that we have, 2y plus 6 over y squared plus 2y, and break this down into the partial fraction decomposition. Okay. To do that, we have to factor that denominator. All we can do factoring that denominator is to pull a y out of there. But that leaves us with two linear terms. So we're going to have a fraction over that first linear term y, and a fraction over the second linear term y plus 2. Same thing, we need to get the coefficients there, the a and the b, and to do that we're going to multiply both sides by that denominator. So we get 2y plus 6 on the left. When I multiply by this denominator on the first fraction, the y's cancel, the a comes down, and we get that linear factor y plus 2. On the second fraction, the y plus 2's cancel, the b comes down, and the y. Again, you can answer this however you like. Either method, whether it's the method where you're plugging in different y values, or you could do the method where you're looking at the coefficients. It doesn't really matter, and this one's so easy you could probably do both. Let's do the coefficient one since we did the other one last time. So what we need to do is we're going to multiply out these parentheses. Then we have different y coefficients. On the left-hand side, the only coefficient I have on y is a 2. On the right-hand side, I have a y plus by, so a plus b. Then we also have constant coefficients floating around. On the left, I have 6. On the right, the only thing that I have that does not have a y on it is that 2a. So this one gives me a is equal to 3. If I plug 3 into the first equation and subtract it over, it gives me b is equal to -1. Okay, and then just remember that the a, which is 3, was over the y. The -1 was over the y plus 2, which means that my integral now, still going from 1/3 to 1, is now going to be a, 3 over y, and we'll go ahead and end that one, plus another integral, 1/3 to 1, of b, -1 over y plus 2. All right, so we're breaking up that more complicated rational function into two separate rational functions that are much easier to deal with. All right, so for both of these, I'll do these kind of quick, especially this first one. We would take the 3 out, and then we're left with 1 over y dy, which is the natural log of y. And we're going to evaluate that from 1/3 to 1. plus, same thing over here. We're going to take that negative 1 out, and then it's going to be the natural log of y plus 2, and then that we're going to evaluate from 1/3 to 1. Okay, so that's kind of gross looking. I'll try and write it a little bit nicer. It's so hard to write on this screen. Not that my handwriting is amazing anyway, but this, like, writing on a laptop just exacerbates it and makes it so much worse. That's a little bit better. Okay, so then we just plug in the limits. So we're going to plug 1 into this first one. So I'll just write it all out. So it's going to be 3 natural log of 1. That is going to come out to be 0. Minus 3 natural log of 1/3. Plus, same thing with this other bracket over here. We're going to plug 1 in, which is going to be negative natural log of 3. And then plus natural log of 1/3 plus 2 is 7/3. You can drop the absolute value, right? Because you know the number on the inside is positive anyway. Okay, now it's all just about simplifying it. I promise you that if you plug it into the homework just like this, negative 3 natural log 1/3 minus natural log 3 plus natural log 7/3, it'll count it right. But I'm guessing if you just hit like the help me solve this or the view an example, it might not look like that. So this is just some rules of logs. It's probably been a little while since you guys have looked at any of the properties for logs. But if you have 2 logs that are added together, you multiply the insides. If you have 2 logs that are subtracted, then you divide. Another way of thinking about that is if it has a negative sign out in front, it goes in the denominator. If it has a positive sign out in front, it goes in the numerator. Also, coefficients on logs come in as exponents. So really this first one should be negative natural log 1/3 all cubed. And 1/3 all cubed is 1/27, I think. Okay, so now we can do the trick that we have with if it's a minus sign, it goes in the denominator, plus sign, it goes in the numerator. So this will all combine together to be 1 natural log, where we have 7/3 up top, 1/27 times 3 in the bottom. And you just try simplifying that down as best you can. I suck at this kind of stuff. So it looks like that's going to be a 1/9 now. 7/27, I think, for the final answer. Let's try typing that in and see if that works. Natural log 7/27. Oh no, we goofed it. Alright, I wonder if it's just that part that I messed up. I tried typing in this other thing to see if that was right. Negative 3, natural log 3. What was it? Oh no, sorry, it was natural log 1/3. Minus natural log 3. Plus natural log 7/3. There we go. Yeah, so, I don't know. I made some kind of simple mistake moving down here. The math is right. I'm guessing it's just this part right here that I goofed up somewhere. Or maybe 3 cubed? No, that's 27, right? Yeah. Anyway, it doesn't matter. Just type it in like this. That's one real nice thing about moving on to more difficult levels of math, is that you don't have to simplify anymore. There's no point. Nobody simplifies. Just leave it look awful. Okay, did that help with that one? Does that make sense? Besides the bottom half, we can just erase that. Just ignore that part. Kind of bothering me now that it messed it up. I don't see where their mistake is. Oh, I see where it is. It was this last part. Yeah, this is wrong. Should be natural log of, the 27 comes up top. 27 times 7 all over 9, which would be natural log of 21. I should have typed that in. I can't redo it now, unfortunately, but natural log 21 probably work here. Okay, I feel like I'm rambling now. Any other homework questions? Or life questions? I don't just have to be your calculus teacher. Anybody want to know where to invest their money? Boyfriend, girlfriend issues? I'm all ears. Investment hope. Anytime. Okay, last call. Anybody else for a homework question? Sections 3, 4, and 5. Homework is due this Sunday. Won't talk to you till it's due. How to get a baby to stop crying. When my son was little, what I would do is that I would lay him on his stomach, and then I would just pat the back of his back, and he would stop crying every time. That was the only way I can get him to fall asleep. Other than that, I'm at a loss. But I've only had the one kid that was a baby. So, and he was super cool. He was the most chill baby ever. I got really lucky. Driving works too. Yeah, that was another thing. I'd put him in the back seat and drive around, and he was just out. So that's another thing you can try. Just try, put him in the car seat and driving around the block. Or you can teach calculus, because that puts people to sleep. Okay, well, if there's no more homework questions, let's get out of here. I'm kind of hungry. I'm going to go get a snack. I think some apple pie downstairs with my name on it. And we'll have another one of these meetings next Tuesday and next Thursday. Those are the last 2 meetings before the Chapter 8 test. So I really want to kind of dive in and do a lot of examples, either from the Chapter 8 practice stuff, or of course, if you guys have specific homework questions, we can look at those too. So the meetings next week might be a little bit longer, just because I want to do as many practice problems as we can before the test. But we'll call it here. Thanks for coming. This is recorded, so if you want to watch the recording, I'll put it up in Moodle. And I will see everybody hopefully next Tuesday.